Performing analog input is a widely used function of the USB 6211. With 16 analog input channels, you can acquire quite a few signals. The total throughput of the device is 250 kilosamples per second. So let me first describe my hardware setup here. This is the USB 6211. We have our analog output and digital I/O section over here, and here's our analog input section right here. What I have set up on this breadboard are two potentiometers, and we have a 5-volt output of the 6211 that's coming over, and we're using it to power or give a high side to our potentiometers. Coming out of the potentiometers, we have the low side signals going back to the ground side or the low differential side of our analog input channels, and then we have those wired over here to the system ground of the USB 6211. In the center of the potentiometer, with a voltage that's going to vary with the motion on the potentiometers, we have a signal feeding right into our analog input channels 1 and analog input channels 2. So this is our setup. Now let's switch over to LabVIEW and take a look at our graphical programming language that makes setting up data acquisition tasks straightforward, but can also scale to complex applications as well. So the first thing that we're going to do from our blank front panel is put down a waveform graph. So we'll set this down here and we'll stretch it out a little so that you can see it. And then we're going to scale this from 0 all the way up to 5 volts so that we'll set the range that we want. And the reason that we're doing that is here on our output we have 5 volts that's giving us the highest value we'll see off the potentiometers. Okay, we're also going to tell it not to auto scale so that we can make sure that we'll have our range set. And then we want to change the line thickness so that you'll be able to see these lines in the video. Next thing that we're going to do is we're going to go back to the block diagram. And in the block diagram, we want to drop down the DAC assistant. And this is going to allow us to specify the parameters of our data acquisition task. So we drop down the DAC assistant. We'll tell it to acquire signals, do analog input, and voltage. And then we want to acquire on 2 channels, and we have selected AI1 and AI2. So we'll finish that up, and then we'll specify just a few more things. All we have to tell it is that we want to acquire samples continuously. We want to tell it that we want to sample 5,000 samples every time we go through our loop. And then finally, we want to do this at a high rate of speed, at 100,000 samples per second per channel. So that gets us to an aggregate rate of 200,000 samples per second in this acquisition task. So we'll say okay there. This is going to build our function for us on the diagram. And yes, we will put this inside a loop because it's a continuous acquisition and we'll do it over and over again. So the next thing we do is we put our waveform graph inside the loop and we wire this up, and we're pretty much ready to go. We'll go back to the front panel, we'll click the Run button, and now we're acquiring our 2 channels of analog input. Now I'm going to take the screwdriver and I'm going to insert it into the potentiometer here, and when I turn this, you're actually going to see that the waveform moves on the screen there. And that's an independent channel from my second channel, my AI2 channel. And when I put this in here, you'll see that they run independently of each other. So what you're seeing are snapshots of 5,000 samples at a time, and these are being acquired at 100,000 samples per second per channel. So this is how you would set up and do analog input acquisition with the USB 6211.